Hello everyone, welcome back. Let's solve the problem C from the weekly contest 385, most frequent prime. So first let's understand the problem statement. So before understanding the problem statement, first let's see the constraints. If you see the constraints, my n and n are pretty low, like around 6, and my math values are till 1 to 9. So I think brute force, any type of backtracking will work, because the maximum it can go till factorials, 7 factorial, which is 720, or it can go to 2 power 6 or 3 power 6, 4 power 6, anything it is going, like we can manage it out. Now let's understand. You are given an m cross n 0 index 2D matrix mat. From every cell you can create numbers in the following way. Is saying that there could be 8 most parts from a cell, namely is saying that there will be 8 parts. That means when you are at this location x comma y, you can go here, or I can go here, this position, this and this. You can calculate what can be this if it is x comma y. So if we are considering this, it will be x comma y plus 1, right? Y plus 1, yeah. When the Cartesian product, if you draw from this location, it is y plus 1. Now if you see here, this can be x plus 1 comma y, and this will be x plus 1 and y plus 1. In this way, like every node can be calculated. Now if you see here, this can be x comma y minus 1, this will be x plus 1 y minus 1. Now this x minus 1 y, now this node can be x minus 1 y minus 1, and this is my x minus 1, and we are going with y plus 1. So these are all 8 nodes we have there. We need to select a path from them and append digits in this path to the number being found by traveling in this direction. Okay. Note that the numbers are generated at every step. For example, if the digit along the paths are 191, then there will be 3 numbers generated, 1, 19 and 191. And we need to return the most frequent prime numbers greater than 10. Is saying that the prime number should be greater than 10 out of all numbers created by traversing the matrix, or minus 1 if no such prime number exists. So if you think, if you have something like this, and if you have 2 is a prime number, sorry for that, 4, in this case there will be no prime numbers formed, so you will return minus 1. And it is invalid to change the direction during the move. It is the most important thing. So I think most of you have done the problem, and this point you have missed it. Suppose if you are at this position, and if you are going towards the east, then you should go towards the east. Now if you are coming here you don't have 8 paths, you have only the east path. Suppose you are going northeast, if you are at this position, you don't have the 8 paths to move, you only have one path. Saying that we can't change the direction during the move. So this is the most important thing, remember this. Now if you see this example, we have 1, 1, so we are going this side, and we are telling 1, 1, 11 and 1, 9. In this way, from cell 0, 0 we have calculated. In the same way 0, 1, 1, 0 we have calculated, and we got the 19 as the most frequent element. So if you see here, we have the prime numbers. So to calculate the prime numbers efficiently, to find out the number is a prime or not efficiently, we have Sieve algorithm. So you can browse Sieve of Erasmus. I did not remember exactly. Sieve of Erasmus. This is the fastest algorithm to give you the prime numbers. So I have used this algorithm to calculate the prime numbers. So first thing, you will calculate the prime numbers. This is the prime number Sieve algorithm. So you can check it out. Because this is not in the scope of this concept. So that's why I am not able to explain, because this video will be very much long if I explain this thing. Now let's see, after getting the Sieve, after calculating the primes, so you'll get to know whether the number is a prime or not in order of 1, because we are using boolean and we are keeping true or false, so it will be like order of 1. Now for every move we will iterate 2 loops. For every move we have 8 possibilities, right? We have 8 possibilities. I can choose any one of this. If I am choosing any one of this, and we should follow that direction only, that's why I have implemented dx and dy. Dx is something 0, 1, 1, I am storing 0, 1, 1, 1, 0, minus 1, minus 1, minus 1. Same thing with y, 1, 1, 0, minus 1, minus 1. In this way dx and dy has been stored. Now we will iterate I is equals 0, I less than n, j is equals to 0, j less than m, and we are visited. This is not required definitely, because we are going in a single direction, so we will not go, visited is not required. Now k is equals to 0, k less than 8, because we have 8 possibilities, that's why we are going with k less than 8. Solve I, j, n, m, forget about this visited, we have k as my index. Now s is equals to 10 into s plus v of ij. That means here is saying that we are at 1, then we are going for 9, then what we can do, 1 into 10 plus 9, we will get 19. We are at 19, now we got 3, we got 190 plus 3, we are getting 193. That's why we are multiplying into 10 plus v of ij. If that is my prime, I am incrementing that frequency, then we are only going for k direction. That means only we are choosing the direction which we are moving, I plus dxk, j plus dyk, and my int I and j, nm. So it is straightforward. So after calculating it, we are calculating the maximum frequency here, maximum frequency. After calculating the maximum frequency, we want, after getting the maximum frequency, if my frequency is matching, suppose for 2 my frequency is 5, but for my 5, 2 is not considered because the number should be greater than 10. So if you are going with 11, my frequency is 5. For my 19, my frequency is also 5. So in this, we need to choose the maximum element. That means you should choose the 19. If my frequency is maximum, you should consider the element. So here I am showing answer equals to maximum answer comma I dot first. So this recursive solution is pretty easy. I think you understood it, what we have done, I plus d of x, j plus d of y, that's it. There is nothing much involved in this. In this, recursion is also not required, we can directly go, we can directly compute here also. So better readability, we can use this. So I think you have got it. So if you see here, the time complexity can be, suppose if you are starting at any node, you can go till height of this node, right, height of this node. That means we have maximum of 6 elements, so every time it will go till 6. So it will be like order of n square mostly, it will be like order of n square. So I think you have got it. So if you understood and if you learned something from this video, please consider to like and subscribe. So I will see you in the next video. Till then, bye bye. And one more thing, guys, I have created a WhatsApp community. So in that community, we have different people where we will discuss the problems from the weekly contest. So if you are interested, you can join that community. Bye bye.